solving linear equations, and also solving quadratic equations by factoring. So at its simplest, solving a linear equation could be something as simple as 3x is equal to 12, and what we need to do is get x, so let's divide both sides by 3, and x is equal to 4. Slightly more complicated, 5y minus 2 is equal to 3y plus 4. Now in this instance we want to isolate our variables, the y's, on the left-hand side and our numbers on the right-hand side. I'm going to do that by subtracting 3y from both sides, giving me 2y, and adding 2 to both sides, giving me 6, at which point we default to this, which is simply divide both sides by 2 and end up with y is equal to 3. We could get a little bit more complicated. Let's do something with some brackets perhaps. So let's say we have something like 3 times 2 minus z is equal to 7z plus 12 minus 4z. I'm running out of space. 4z. Okay, ideally what we want to do is simplify on a side when we can, so simplify first. So I'm just going to multiply this out. 6 minus 3z is equal to 3z plus 12. Now I want to get my z's on one side, ideally the left-hand side, but on the left-hand side this is negative, so I'm just going to think, let's move this over here where it will become 3z plus 3z, or 6z. So we moved it to the right side, but we're going to write it on the left-hand side, equals, and the 12 is going to come over here where it'll be 6 minus 12, negative 6, and we solve, we get z is equal to negative 1. Now if you want to verify your solutions, you can put them back into the original. And the way I do that, let me just move this up a titch, is I do a t-table. So I'm going to say the left side of the equation is 3 times 2 minus z, and close that off. So here's the t-table. And the right side of the equation is equal to 7z plus 12 minus 4z. And now what we do is we treat these independently. Okay, we don't cross over this middle line. We're not solving an equation, we're verifying. So the left side is 3 times 2 minus negative 1, which is 3 times 2 minus negative 1 is 2 plus 1 is 9. And the right hand side we get 7 times negative 1 plus 12 minus 4 times negative 1 gives me negative 7 plus 12 plus 4, which is negative 7 plus 16, which is 9, and that checks. So that's a formal verification using a t-table, right? We split off left side, work it independently, right side, work it independently, always with the original equation. Okay, never with anything down here, because if you made a mistake going to this step here, then you'll be verifying an incorrect answer in an incorrect equation. Alright, so that's solving linear equations, and that's going to come in handy in our next step, which is solving quadratics by factoring. Solving quadratic equations by factoring. This could be as simple as, well, we've got two terms here. It's not a difference of squares, because this does not have a square root. 9 does, but the x doesn't. So at this point we default to common factoring, which is 3x, leaving me with x minus 3, and that's equal to 0. Now solving by factoring involves something called the zero product principle, which says that if a times b is equal to 0, if the product of two things is equal to 0, then either a is equal to 0 or b is equal to 0, or both a and b are equal to 0. In other words, if we're multiplying two things together and we're getting 0, then one of them has to be a 0. So in this case, solving this means that either 3x is equal to 0, divide both sides by 3, we get x equals 0, or x minus 3 is equal to 0, add 3. And this is just linear, right? Like we did in the last one, this is just a linear, and so x is equal to 3. Okay, let's go on. Let's do something a little bit more challenging. So let's take a trinomial. X squared plus 11x plus 28 equals. Now, before, what we were doing in the last year was just factoring this, but now we're setting it equal to 0. That gives us a quadratic equation. Equation needs an equals. Okay, we're going to factor this. X plus 4, x plus 7 equals 0. And I'm just solving these by inspection at this point, so that means that x is equal to negative 4 or x is equal to negative 7. Okay, we can state that as a solution set using brace brackets, negative 4, negative 7. Okay, we can verify that by plugging in. I'm just going to do a quick mental substitution. Negative 4 quantity squared, which is negative 4 times negative 4 is 16, minus 44 is negative 28, plus 28 is 0. Put in negative 7, we'll get negative 49, we'll get negative 7 quantity squared, which is positive 49. I'm starting to make the mistakes you guys do. 49 minus 77 is negative 28, plus 28 is equal to 0. These are, in fact, the solutions. And remember, anytime you factor, FOIL it out. X squared plus 7x plus 4x gives me the 11x plus 28. Factoring is now a tool that's going to be used to solve these problems, right? To solve quadratic equations by factoring. Okay, let's step it up a notch. I'm just going to pull a couple of questions out of the factoring strategy. You know, we did quite a number of days on factoring, and let's find one that's, what do we got? Oh, here's a nice one. Well, this is a variation. Let's call it 6x squared minus 23x plus 15 equals 0. So the idea is we have to factor this. Alright, so for the factorization, usually it's going to be a 2x and a 3x. Now I factor by guess and check, so that's my guess. And I'm guessing that I'm going to need a 5 and a 3. So if I put the 5 there, I can get a 10 and a 9 with the 3 there. That won't give me a 23. They're both minuses. So how about if we put the 3 here and the 5 here, 15 and 6. That won't give me 15 and 1. I can get a 31. No. Okay. Let's haul out the eraser. And let's change this to a 6x. And change this to a 1x. Okay, let's try that. Oops, back to pen. So what if we have 6x and 1x? Then how are we going to get this 23? We know they're both negatives, right? I mean, they have to be, since the last term is positive. So I'll get a 6x squared. Now let's try 5 and 3. If I put a 5 here, I'll get a 30, too big. So then let's try a 3 here. That'll give me 18. And a 5 here, that'll give me the 5. All right, 6x squared minus 18x minus 5x is minus 23x plus 15. Nice, we have the factorization. Solve by inspection. X is equal to, we change the sign, positive, we take this term 5 over 6, and x is equal to 3. A more formal method, right, if you're not seeing this, would be to write 6x minus 5 equals 0, right? Refer to the zero product property. Either this expression is 0 or this one. I mean, they both can't be in this case because they're different. So 6x is equal to 5. Add 5 to both sides. This is linear, just solving a linear. And x is 5 over 6. And so we will express our answer in the form of set notation 5, 6, comma 3. I'm going in order from lowest to highest here, although I didn't really do that over there. As long as they're both in there, do not put these in round brackets, okay, or parentheses. If you do that, this is an ordered pair, which is a point on the coordinate plane, and we don't want that, right? It's so bad that we'll never do that, okay? But you can express it this way. All right, let's see what else we can do by factoring. Let's take something that's just a step up above this. I'll be back in a sec. Okay, here we go. Here's a little more complicated difference of squares to factor. Now, you could actually expand this out, 4a squared plus 12a plus 9 minus, and you could expand this, a squared minus 4a plus 4, but that means you've got to multiply out two binomials, or rather square two binomials correctly, get the minus sign right, and then distribute that properly through a set of brackets, and eventually end up with something that would factor and from which you could find the answers. If you recognize this as a difference of squares, you can save yourself quite a bit of work. So I recognize, hey, this is a difference of squares, so it's the square root of 2a plus 3 squared, which is 2a plus 3, plus the square root of a minus 2 squared, or just a minus 2, and then we repeat 2a plus 3 minus a minus 2 equals 0. I don't really need the brackets in this case since it's a plus. I do need them here, okay? I need to be reminded. I'm going to show you a little more full detail than probably I would normally do this, but 2a plus 3 plus a minus 2 and 2a plus 3 minus a plus 2, okay, watch your signs, equals 0. Normally I would have just gone from this line here directly to what I'm now about to write, okay, which is 3a. I would have looked here and said, okay, 3a, 3 minus 2 is 1. And I would have looked here, 2a minus a is 1a, and 3 minus negative 2, which is 3 plus 2, gives me 5, and that's equal to 0. Now, I cannot check this by expanding it back out, right? Getting 3a squared plus 16a plus 5, because I have nothing to look at here that's in that form without actually expanding this. So here's what we'll do. Let's solve this. Okay, so this one is a is equal to, opposite sign, negative 1 over 3, and a is equal to negative 5. That's my solution. Let's go in and check that. Okay, so we'll do a left side, right side. In this case, the left side is the most exciting because the right side is simply 0. So the left side is 2a plus 3 squared minus a minus 2 squared. And let's leave some space, and the right side is equal to 0. So let's go here. How do we check? We think a is negative 1/3. So everywhere we see the a, we're going to substitute negative 1/3 plus 3 squared minus 1/3 minus 2 squared. Okay, we're going to have to do a little fraction working here. So let me just move down. Let's give some space. Extend this down a bit. So this is negative 2/3. And 3 is 9/3. Negative 2/3 plus 9/3 is 7/3 squared minus, and this is 1/3 minus 2. 2 will be 6/3. So this will be, remember, that's a minus. And it might not look like it. Let's put that in there to make sure we know that that's a minus 1/3. So minus 1/3 minus 2 is minus 7/3 squared. Okay, so we get 49/9 minus, when you square a negative, you get a positive, so this is 49 over 9, which is equal to 0. So that's a check. And let's go through and do the same thing and check it with -5. Run out of space. So let's just go squeeze that over here. Left side equals 2a plus 3 all squared minus a minus 2 all squared. And the right side, this is your t table, right? Looks like a t. Right side is equal to 0. Now we go in, we substitute wherever we see a, we're putting in a -5. Okay, plus 3 squared. And watch your signs. -5 minus 2 squared. Okay, 2 times -5 is -10, plus 3 is -7, quantity squared, minus -7, quantity squared, which we could see is going to be 0, right, since we're squaring, and it's the same thing anyways, and 49 minus 49 is 0. That's how we can check that this is the solution to the original, which is up here. Okay, by substituting, again, we substitute into the original, not into a simplified form. If we made a mistake somewhere, we will have a solution to the mistaken equation, but not to the original equation. Okay, one more just to practice our factoring, and then we'll be done with this. Okay, here's another one. Now this doesn't look like a quadratic equation that we can solve by factoring, since it's not equal to 0. It's equal to 11 times 2x plus 1. But if you'll note, you say, hey, wait a sec, I have something which is being squared, and I have the same something. So let's just bring it all together. And really, in order to solve by factoring, you must have the right-hand side equal to 0. That's what allows you to use the zero product principle, or the zero product property. And that is equal to 0. Okay, I'm going to change this. I'm going to make that a minus, so over here it'll be a plus. Okay, so changing the original just to give me something that actually will factor. Okay, if you like, we say let a equal 2x plus 1. In other words, we're solving a simpler problem, which is 15a squared plus 11a minus 12 equals 0. We factor. I'm guessing. Usually it's 5 and 3. I need to get 11. I've got 1 plus 1 minus. The plus is going to be bigger, so 12. Let's see, we put a 4 there. That'll give me a 20, and a 3 there will give me a 9. And that's what I want. And I know that the 4 has to be the plus to give me the larger, so we get 15a squared plus 20a minus 9a is plus 11a minus 12. Now, what do we want to do at this point? Well, we could put the 2x plus 1 back in here, or we could solve for a and then substitute this and then solve again. I think maybe what I'm going to do is just put the 2x plus 1 in and simplify at this point, and then we will solve. Okay, so 2x plus 1. Okay, so just in one fell swoop, this is 10x plus 5, so it's 10x plus 5 minus 3. 5 minus 3 is 2, so 10x plus 2. And this will be 6x. That's the only x's we've got. Plus 3 plus 4 is plus 7 equals 0. Now, do I need to factor the 2 out of here? Well, I need to simplify. So we could say x is equal to -2 over 10, right? That's going to be change the sign negative, and then reduce, which is -1/5. Okay, if I factor the 2 out, then we'll get directly to the -1/5. But if I don't, we can still get there. We'll just have to reduce. And this is equal to, x is equal to -7/6. Solution set. Okay, set brackets, right? Brace brackets. -1/5, -7/6. And I leave it as an exercise to you to substitute that in and check it if you so desire. Okay, this completes linear and solving quadratics by factoring.